Okay. So there is again a correction in my previous module. Okay. So for soft clays, gamma H over C is greater than 4. And for stiff clays, this is gamma H over C, or the cohesion value C, is less than or equal to 4. Okay? So last meeting, umabot tayo hanggang brace sheeting in sand layer. Okay, this one. Okay, for for today, we'll be discussing brace sheeting in clay layer. Okay? So again, this is a pass board exam last November 2005. Okay. Dagdag ko lang, this examiner, yung examiner ng I think before yung examiner natin ngayon sa Hydra Geo, Hydraulics and Geotechnical Engineering. Okay, napaka favorite nito yung yung mga foundation designs, ay mga foundation solutions, kay mga retaining walls, yun, napaka-favorite nung examiner na to. Kaya kung mapapansin nyo, nung May 2005, nagbigay siya ng brace sheeting in sand layer. Then nung November 2005, nagbigay ulit, pero clay layer naman. Okay? So, sige, let's start. So a brace cut shown in the figure has strut A, B, and C with 5 meter spacing on center. Okay, ibig sabihin 5 meter yung spacing niya away from your monitor. Okay, so this one, 5 meters yung strut spacing niya. Okay, so the question is using PEX empirical pressure diagram, and the assumption is soil is stiff clay, or we will check if that is a stiff clay. Okay, so the same to previous example, we will compute the strut load at A, the strut load at C, and the strut load at B. So given it is a medium clay with a unit weight of 17.5 kilonewton per cubic meter, a cohesion value of 30 kilonewton per square meter, and an angle of internal friction to be assumed to be equal to 0. Okay, and the total height of our retaining wall is 7 meters. The distance between strut A and strut B is 3 meters. And for strut B and strut C is 2 meters. And the distance from the ground level to strut A is 1 meters. And the distance of strut C to the bottom level is 1 meters. Okay, so ayan. Okay, so first we will check if our so we will check if our strut load is, if our brace sheeting is a stiff clay. Okay, so to determine if our soil is stiff clay, we use a notation gamma H over C. Okay, so therefore your gamma is 17.5. The total height of your retaining wall is 7 meters. This one, 7 meters. Okay, divided by the cohesion value of 30. Okay, so gamma H over C, we have this 4.08. So going back to the assumed earth pressure envelope or earth pressure diagram, when gamma H over C is greater than 4, the assumption is a soft clay. Okay, this one. So meaning, ito yung pressure diagram natin. So linearly increasing in 0 to 0.25 H, and uniform pressure from 0.25 H to 1.0 H. Okay, so that is our pressure diagram. So therefore, our pressure diagram is this one. So solve first the first quarter of the heights, or 0.25 H. That is 0.25 times 7, you got 1.75 meters. Okay, then 0.75 H, you get 5.25 meters. Okay, this one. Okay, so the pressure diagram will be this one, RA, RB, RC, 1.75 and 5.25 with a pressure of gamma H minus 4C. Okay, so saan nang galing tong gamma H over minus 4C? Okay, in the formula, so formula natin, we have here gamma H multiplied by 1 minus 4C over gamma H. So distribute mo lang yung gamma H, you get P is equals to gamma H minus 4C. Okay? Dito lang yan. I-distribute mo lang. So, okay. So, yan. Ito yung ating value. So, gamma H is 17.5 times H times 7 equal minus 4 times 30. You have this pressure to be 2.5 kilonewton per square meter. And take note again that the strut loads may be determined by assuming that the vertical members are hinged at each strut level except the topmost and the bottommost one. Okay, so meaning the only hinge, okay, assumption is at point B, okay, or the strut load, the strut level at B. Okay, so therefore, ito lang yung hinge. Okay, so recall your strength, your theory of structure. So for kapag may hinge, we can we can separate, okay, yung taas and yung baba. Okay, separate the hinge, and the reaction will be divided into two. Okay, meron kang RB1 and RB2. Okay, and the total reaction at B is the sum of the contribution of RB1 and RB2. Okay, so considering the top of RB, the top of the strut load at B, so considering the top pressure diagram. Okay, so using this stress diagram with RA, RB1, okay, so taking the moment at B, since we are assuming that at point B, there is no rotation or there is no moment, okay? So taking the moment at B, so some 3 times RA, okay? The distance of RA to RB, that is 3 times RA. Then 2.25, 2.5 times 2.25 times 5. Take note that you have 5-meter spacing on center. Okay, and you have this 5. Then the distance, the centroidal distance of this pressure diagram, natin yan to sa into 2, is 2.25 over 2, which is this one. Next is this pressure diagram, this linearly increasing pressure diagram. Okay, so for this linearly increasing pressure diagram, basically that is 2.5 base times height over 2. So 2.5 times 1.75 over 2. Okay, multiplied by 5-meter spacing on center. Okay, this one. And the centroidal distance of the pressure diagram to RB1. Okay, so ito siya, this distance. Okay, so that is 1.75 over 3 plus this plus, so not this one, plus 2.25. So this will be plus 2.25. So that is this centroidal distance of pressure diagram of linearly increasing. Okay, so therefore you get RA to be 20.88 kilonewton. Okay, so that is the strut load at A. Okay, now solving for strut load at C, first we need to find RB1. Okay, so hanapin muna natin yung RB1 dito. So dapat nandito siya sa taas. So anyway, summation forces along horizontal equals to 0. Okay, RA okay, minus yung ito. So 2.25 times 2.5 times 2 minus 1.75 times 2.5 over 2 times 5. B times by 2. This should be 5 times 5. Okay, so you have here RB1 to be equal to uh, 39.06 minus 20.88. You have 18.18 kilonewton. Okay, that is your RB1. Now considering the bottom of hinge strut at B, okay, considering the lower part. Okay, so the lower part has this pressure diagram. Okay, so this is RB2. Okay, this is RC. Okay, so the strut load at C, so taking summation moment at B equals to 0. So the distance of RC to RB for strut load at B is 2 meters. So 2 times RC is equals to 2.5. Okay, ano yung natitirang distance na to? That is 3 meters. Okay, this one, that is 3 meters. Okay, the sum of 2 and 1, that is 3 meters. Okay, then take note again, you have 5 meter spacing on center. Okay, so that is why you have this 5. And the centroidal distance of the this pressure diagram to RB2 is 1.5 or 3 meters over 2. This is 3 meters over 2, or that is equals to 1.5 meters. Okay, so therefore our RC is equals to 28.13 kilonewtons. Okay, and for solving strut load at B, so just solve for RB2. Okay, so RB2 plus RB1 is the total reaction at B. Okay, so summation forces horizontal equals to 0 in solving RB2. RB2 plus RC is equals to 2.5 times 3 times 5 meter spacing. You have here RB2 to be 9.37. Okay, so solving for the strut load at B is just simply the sum of RB1. Okay, so RB is equals to RB1 plus RB2. Therefore, you have 9.37 plus 18.18. You have here strut load at B to be 27.55 kilonewtons. Okay, so ganyan lang yung pag-solve for brace cuts or the lateral pressure on brace cuts. Okay, so after nyo makuha yung mga strut loads, okay, you can now solve, you can now design your bracing. Okay, okay, yung bracing mo na yon, maybe that this load is your axial compression or axial tension. Okay, that is your axial compression or axial tension, or axial tension. So if you're using steel, okay, steel yung bracing mo, and let's say LRFD, so you can check the provisions for design of axial compression or axial tension in LRFD for steel. If you're using timber, maybe you can check the provisions for timber working stress design in axial compression and axial tension. Okay, so that is how you analyze the lateral pressure and the forces on brace cuts. Okay, so do you have any more questions about brace cuts and the PEX empirical formula? Okay, again, there is a correction. So for subclase, we have gamma H over C greater than 4. And for stiff clays, you have gamma H over C less than or equal to 4. Okay? So ito lang yung correction natin. Okay. We have here a cantilever retaining wall. So before I discuss the solution for cantilever retaining wall, let us first understand what is a cantilever retaining wall and ano ba yung mga properties na ito. Okay, ano ba yung retaining walls? one. This one. Retaining wall. Okay. Again, our cantilever retaining wall is this one. You have here a vertical stem, a monolithic with the base or non-monolithic with the base. This one. Okay, the slender section can be used in retaining wall. And you have here a cantilever type. Kaya siya tinawag na cantilever is meron siyang naka-insert dun sa backfill. Okay, nakaganyan. So there is also a different type of cantilever retaining wall. Okay, ganito naman yung style niya. Okay. Of here. Then meron minsan na nakapasobra dito sa labas. Okay, ayan. So, ayan. So for this type of cantilever retaining wall, okay, we all know that this is your toe and this is your heel. Again, kailan malalaman if where is your toe and where is your heel? Okay, so first you need to find to determine where is your active side. So, na-mute pala. Sorry. Okay, again, ano nga to? Determine where is your active side. Okay, for example, you have two different height of soil. Okay, so let's say ito, mataas yung soil mo dito sa kabila, dito naman yung soil. Again, the active side is always kung saan yung may mataas na soil. So therefore, this is your active side. Okay, again, active side is kung saan yung may mataas yung soil or mas mataas yung lateral pressure. Okay? So pwede rin mangyari kung ito sobrang laki naman ng surcharge load dito wala, pwede mangyari ito rin yung active side. Okay? So meaning the active side is kung saan may mataas na lateral pressure. So for our case, since let's say wala naman tong surcharge load, so we can easily determine that the active side is at this location. Okay? So the active side, ibig sabihin yan yung tutulak. Okay? Ibig sabihin ito yung tutulak doon sa ating cantilever retaining wall. So therefore, kung makapapansin niyo yung sa heels, pagsusot ng heels, 'di ba, you have this ito. Okay. Paano ba yun? Yan yung heels, okay? So 'di ba, nandito yung toe natin, ito yung heel. Okay, this one is your heels. Okay? So ganito rin yung mangyayari sa ating cantilever retaining wall. This will be your toe and this will be your heel. Ito yung aangat. Okay? So yan yung toe and heel. Okay, next. What is a toe slab and heel slab? Okay? So this is our slab. Okay, this is our slab. Ibang kulay. Okay. So this is our slab. Ito yung tinatawag na slab. Yan. So since you have sorry, bakit heel? H-I-L-L should be H-E-E-L. Okay. Bakit ito? Heel. Okay. So since you know where is your toe and where is your heel and this is your slab, okay, therefore we call this one as heel slab. This one is your heel slab. And we call this one is as okay, we call this one as toe slab. Okay, and this one is your stem. This one is your stem. Okay. Again, this one is your heel slab. This one is your toe slab. And itong nasa gitna is your stem. Okay? So yan yung mga properties of a cantilever retaining wall. Okay? So going back to our problem, let's solve this one. Okay, this one. So going back to our problem, we have here a cantilever retaining wall. Okay, the section of reinforced concrete retaining wall is shown in the figure. Okay, you have here 0.4, 0.5, and 3.6 dimensions. Okay, 1 meter yung toe slab dimensions and 2.2 meter yung heel slab dimension. And the total height of your cantilever is 5.5 meters. Okay, there is a surcharge load of 12 kPa at the surface of the backfill and using the NSCP 2010. Okay, the data of our cantilever retaining wall is given. Unit weight of concrete to be 23.5, the unit weight of the soil to be 17, the angle of internal friction to be 35, the coefficient of friction between the soil and concrete, let's say that is mu, that is 0.5. The allowable soil bearing capacity is equals to 200 kPa. The minimum factor of safety for stability against sliding is 1.5, against overturning is 2.0. Okay, determine the stability factor of safety against overturning. The answer is 3.8. And determine the stability factor of safety against sliding. The answer is 1.73. Okay, let's us try to solve this one. I-solve natin siya. Solve natin sa whiteboard. Okay. Can you see, nakikita niyo ba yung whiteboard?
Po, sir.
Okay. So yung analysis dito is simply the same sa analysis sa dams or in your fluid dynamics. Okay, so hahanapin lang natin yung vertical forces, yung horizontal forces, then hanapin natin yung overturning moment and righting moment. Then recall the formula for factor of safety against overturning, factor of safety against sliding. Okay, so the formula for factor of safety against overturning, you recall in your fluid in analysis of dams, is basically yung righting moment or yung tutulak divided by dun sa overturning moment or yung kokontra. Okay? Again, the factor of safety against overturning is the righting moment divided by the overturning moment. Okay? So ito yung tutulak based from due to lateral forces, tutulak, and overturning moment is yung pipigil. Ito yung due to vertical force. Then the factor of safety against sliding is equals to, okay, basically yung friction, okay, diba? The friction and yung lateral force. Okay? So yun lang yung yung factor of safety against sliding. So how to get the friction? Yung friction is, 'di ba, based on physics, 'di ba? The friction is the normal force multiplied by the angle of the coefficient of friction. Okay? So since we have this coefficient of friction to be mu, okay, therefore our frictional force is equals to mu Ry. So we call it Ry is the total vertical forces. Okay? So if you recall, the factor of safety against sliding is mu Ry over Rx. Okay? Ibig sabihin, you have here the frictional force, yung kontra sa lateral force Rx. Okay? Again, you have here yung force na your capacity divided by your yung tutulak. You have here this one. Okay? Okay, sige. Next is, okay, this one. So, alam na natin yung factor of safety against overturning and a factor of safety against sliding. So, this will be our working equation. So, kunin lang natin itong picture na to. So, kunin ko lang yung picture na to para yun na lang yung gagamitin kong diagram. Okay, this one. Okay, ito. Okay, for our analysis, so we will consider this as W1. Okay, consider na lang natin to na W1. Kita ba? I think mas maganda kung black. So, hindi pa rin. So this one. So W1 and this one is W2. Okay? And this whole unit weight of soil is, let's say, W3. Okay? The total weights yung pababa is W1. Ito yung slab. W2 is yung stem. Okay, ito yung cut. This will be the cut. Okay. W3 is yung soil na babagsak dun sa steel slab. Okay, so tutulong din yung soil na yan, di ba? And also this surcharge load, okay, we say this is W4. So again, W1 is this one, yung slab. W2 is yung remaining for the stem. Okay, W4. W3 is yung soil and W4 is yung surcharge load. Okay. Then for the horizontal force, okay, the pressure diagram for horizontal force is due to soil. Recall this one is due to soil. Okay, soil. And due to the cohesion. Okay. So this is due to soil. And this is due to surcharge load. Okay, so due to soil, that is Ka gamma H, and due to surcharge, that is Ka QKA. Okay, so for Ka gamma H, so first we need to solve for Ka. Yung Ka natin is equals to ano ba yung Ka natin? So 35 degrees. So 1 minus sine 35 degrees divided by 1 plus sine 35 degrees. That is equals to 0.271. So 0.271. Okay, then solving for Ka gamma H, you have here your gamma is equals to 17 and your H is equals to 5.5. You have here 25.3385. Okay, so that is 25.3385. And your QKA is 3.252. 3.252. Okay, so this will be our lateral forces. Okay, so we call this one as P sub 1, and we say this one as P sub 2. Okay, so we can now set off the vertical forces and the horizontal forces. So solving for vertical forces, so this one, vertical. So vertical forces, Okay, so vertical forces. So solve natin isa-isa. For W1, that is the unit weight of concrete given, that is 23.5 times 3.6 multiplied by 0.5, and consider 1 meter width. Okay, consider 1 meter. You have here 42.3 kilonewton. Next, solve for W2. W2 is basically 5.5 minus 0.5, that is 5 meters. Okay, then the thickness is 0.4. So therefore, you have here 23.5 multiplied by 0.4 multiplied by 5 meters multiplied by 1 meter strip. You have here 47 kilonewton. Okay, next, solving for W3 due to soil. So for W3, you have here 17 kilonewton per cubic meter, the unit weight of the soil. Okay, multiplied by this area. So ano ba yung area na babagsak na to? Yung volume na to. So that is 2.2 meters multiplied uh, by okay, by 1. Okay. 2.2 meters multiplied by 5.0. Okay, yung 5.0, itong height na to. Multiplied by 1 meter strip, you have here 187 kilonewton due to the soil alone. Okay? Due to the soil that babagsak dun sa ating hill slab. And W4 is equals to dun sa unit, dun sa surcharge load, that is 12 kPa times 0.4 meters, 12 kPa. Okay, 12 kPa. Okay, so 12 kPa, this one. Okay, 12, yan, sorry. So 12 kPa yung babagsakan ng ating ating load. Okay, 12 kPa. Naka-kPa na siya, class. Take note, naka-kPa na siya. So saan babagsak yung surcharge load na to? Saan to, sa tingin nyo saan to mag-a-act? Saan to mag-a-act yung 12 kPa? So the 12 kPa or the surcharge load will act on this hill slab. Okay? So parang ganito yan eh. So meron kang ito yan, di ba? Okay. Okay? So dito mag-a-act yung ating soil and the surcharge load. So meaning this is 2.2 meters and this is considering 1 meter strip. Okay, so this will be the contact area of the surcharge load. So therefore, this W4 is equals to 12 times 2.2 by 1 meters. Okay, so therefore that is 26.4 kilonewton. Okay, so parang ganyan din yung contact area for the soil. Okay, for the soil. So dito rin yung contact area for the soil. However, kasi doon sa soil is naka-kilonewton per cubic meter. So you need to determine the pressure. Okay, so to determine the pressure, you have this 2.2 by 5. Okay, then multiply by 1 meter strip, you have this 187 kilonewton. Okay, so that will be our vertical forces. For the horizontal forces, so for horizontal forces, basically that is P1 and P2 only. So for P1, that is 1/2 Ka gamma H squared, or that is equivalent to the pressure diagram, this one, pressure diagram. So 1/2 of 25.3385 multiplied by 5.5 meters, okay, multiplied by 1 meter strip consideration. You have here 69.6809. Okay, let's say 6809 kilonewton. Okay, and for P2, you have here 3.252 times 5.5 times 5.5 times, considering 1 meter, you have here 17.886 kilonewton. Okay, so that will be the vertical forces and the horizontal forces. So we can now already solve for this one. So factor of safety against sliding. So easily can solve for this one. Okay, so anyway, we need first determine the factor of safety against overturning. Yun muna tayo. So letter A, to solve for factor of safety against overturning. Okay, that is the working equation is RM, righting moment, over overturning moment. Okay, so if you recall in the concept of overturning and righting moment, the overturning moment is saan yung magko-cause ng overturn or yung topple over, di ba? Saan, ano yung moment na magko-cause ng overturn, yung magko-cause ng ganito? Okay? So ano ba yung magko-cause ng ganito? Tama ba na due to this lateral force? Okay? Hindi naman pwede na yung vertical dyan yung magta-topple over. Okay? So due to this lateral force. And the righting moment, okay, the righting moment, yung magpapa-stabilize sa kanya or kukontra dun sa overturning moment will be the total weight of your structure. Tama ba? Yung total weight mo dito, yan yung kukontra dun sa lateral force P. Yan yung kukontra dito sa lateral force P. So this will be your overturning moment and this will be your righting moment. So the factor of safety against overturning is the RM over OM. So let us first solve for overturning moment. Okay, so for overturning moment, the whole moment that will cause the overturn due to this lateral forces. So basically the moment of horizontal forces. Okay, so hanapin lang natin yung distances of P1 and P2 at the toe side. Okay, hanggang dun sa toe. So the distances is 5.5 over 3 for P1 and for P2 that is 5.5 over 2. Okay, so for the overturning moment, you have here P1 multiply by the centroidal distance to the toe, 5.5 over 3 plus P2, 5.5 over 2. Okay, so if you solve for this one, you have here 176.935 kilonewton meter. Okay, then for the righting moment, okay, so basically we take the moment at the toe for all the weights. Okay, so distances of W1, okay, the distance of W1, distance of W1 is 1.8. Kita ba? Okay, kita. Okay. So let us draw it again. Okay. So the distances of W1 is equals to 1.8. Okay. The distance of W2 is, okay, that is 1 plus 0.2. That is 1.2. And the distance of W3 is 3.6. Okay, sorry. The distance of W3 will be 2.2 over 2. This will be 2.2 over 2. Okay. 2.2 over 2. Then this is 1.4. Right? So yung distance mula dito hanggang dito is 1.4. You have your 0.4 and 1. And yung centroidal distance ng W3 is acting on the 2.2 over 2 or 1.1 meters. Okay? So that is the distance of W3. Okay, then the distance of W4 is the same. So the distance of W4 also act on this length. That is 1.4 plus 2.2 over 2. Okay, so we have all our distances. So let us write it in our solution. So the distance of the overturning moment, the writing moment is equals to W1. Its distance to the toe is 1.8 meters plus W2. The distance to the toe is 1.2 meters. For W3, the distance is 1.4 plus 2.2 over 2. And for W4, the distance is the same, which is 1.4 plus 2.2. Okay, if you solve for writing moment using W1, W2, W3, W4, you have here 666.04 kilonewton meter. Okay, so you have here your overturning moment, and you have here the writing moment. So therefore, the solution or the answer for problem A is the factor of safety against overturning is equals to 666.04 divided by 176.935. That is equals to 3.8 or 3.76. So let's say 3.8. Okay, so that will be our answer for problem A. So next problem is factor of safety against sliding. Okay, the factor of safety against sliding is equals to mu Ry, the frictional force, divided by the total horizontal force. Okay, so factor of safety against sliding is mu multiplied by the total vertical forces. The total vertical forces is equals to 42.3, which is W1, okay, plus 47, it should be the in notations. Okay, sorry. So it should be W1 plus W2 plus W3 plus W4. And Rx is equals to the total horizontal forces, which is P1 plus P2. Okay. Therefore, the factor of safety against sliding is 0.5 okay. 0.5, that is your mu multiplied by W1. What is our W1? Our W1 is 42.3, 47. Okay. So 42.3 plus 47 plus 187 plus 26.4 divided by P1 and P2 of 69.681 plus 17.886. The factor of safety against sliding is equals to Okay, that is equals to 1.73. Okay, so this will be our answer for problem B. Okay, so ganyan lang po yung pagsosolve for the lateral, cantilever retaining walls. Okay, so additional problem, what if we need to check if our cantilever design or cantilever retaining wall is adequate or not. Okay, so to determine if that is adequate, we need to check the minimum factor of safety for stability. So our answer for sliding is 1.73 and our answer for overturning is 3.8. That is above minimum factor of safety. Therefore, our design or our retaining wall is adequate to carry this surcharge load of 12 kPa. Okay, so do you have any questions, guys?
Answer.
Wala naman. Okay. So I will upload na lang itong discussion natin sa whiteboard. Okay? So maybe ayusin ko yung tawag dito yung solution for para mas madali niyo maintindihan or makita. Okay? So again, this is a brace cuts and cantilever retaining wall. Okay, so if you have no questions, that will be our discussion for today, and we will not be having meeting for Friday. So asynchronous tayo sa Friday. Okay, so see you on Monday. Thank you, class.
Thank you, sir.